All right, so we're going to spend a few minutes here reviewing how to solve proportions. A proportion, if you remember from your previous math classes, is generally written as a fraction set equal to another fraction. Now, sometimes that second fraction might be just a whole number, or even might be written in decimal form like it is over here. And that's fine. The basic process is still the same. We've got two sorts of situations that we need to learn how to deal with. The first type is when the variable is on the top of the fraction. So it's in the numerator like it is in all three of these. And the second type we need to deal with is when the variable's in the denominator. So there's a little different strategy for each one of these. We'll start with the variable in the numerator. The first thing you need to do is remember that if you are looking at a fraction, that's really just a division. X divided by 12 here. So if I want to get rid of this division by 12 so that I have just what x equals, that means I need to multiply by 12 on each side. So I'm going to do that here. Times 12 and times 12 over here. Now that will cancel the 12 from one side of the problem as we do that. And on the other side, now we just have to do this math. 12, which we could write as 12 over 1 if we want to, is 12 times 6. We do that. 12 times 6, let's see, grab the calculator here, is 72. And then in the denominator we have 1 times 15, or we could just say 15. And we could say x is that fraction, or what we usually like to do with that is simplify it some, or turn it into a decimal. I'm going to go ahead and turn it into a decimal by dividing. So I take 72 divided by 15 now. And I get x is 4.8. And that should be my correct answer. If you aren't sure of yourself and you want to double check, remember you can always substitute that back in and see if it makes the equation equivalent. So if I put in 6 divided by 15 on my calculator and 4.8 divided by 12 on my calculator, both of those two should come out to be the same decimal. So that's a way you can double check and make sure you've got it right. Okay. Second problem here is very similar to the first. The only difference is we have a whole number over here on this side. But remember that 8 can be written as a fraction by just putting it over 1. So if you want to do that so that it becomes just like this first problem we did, you can certainly do that. So in order to solve it now, I have to again get rid of this division. I want to get y by itself, so I need to get rid of the divide by 4. So we multiply by 4 on each side. So times 4 on each side. So the 4's on this side will cancel out. Again, if you want to, you could put that over 1. But on this problem, there's really no point in putting those divide by 1s. We're just multiplying two whole numbers there. 8 times 4 is 32. If you want to put it over 1, you can, but 32 divided by 1 is still just going to be 32. So y equals 32 is the solution to that proportion. If you want to check it out, 32 divided by 4, that would just equal 8, so it does check. Last one, we got a decimal on this side, which remember when we deal with these, a lot of times we would think of it as a fraction, but if it's a decimal, that's just a fraction that's already been divided out. So if I wanted to solve this, I see z is divided by 22, so I'm going to multiply by 22 on each side again to get rid of the division. So times 22 will cancel out, and I got to do the same thing to this side to keep it equal. So 22 times 0.36. Again, if you want to make it more like the original problem, you can put those over 1, but it's not going to change the values of anything. So all I really need to do here is the 22 times 0.36. And I get 7.92. And if you want to say divide by 1, that's fine, but you don't need it. Okay, so that's how you deal with it when the variable's on the top. The rest of these problems all have the variable in the denominator or on the bottom. Now, in order to solve these, you have to remember a property about reciprocals. Now, reciprocals, remember, mean that you take a fraction and you flip it over. So for example, if I wanted the reciprocal of 1/2, that would be 2 over 1. Well, if I take a proportion problem where I got two equivalent fractions, like 1/2 equals 2/4, if I simplify that 2/4, I would get 1/2, so it is equivalent. And then if I make the reciprocal of that 2/4, that would be 4/2, which, notice, is equivalent to 2/1. So as long as I do the reciprocal of both sides of that proportion, I end up with a new equation that's true. So that's what we're going to do on all three of these down here, is when the variable's on bottom, we're going to make the reciprocal, flipping it upside down, which is going to allow us to solve it just like we did on the top. So let's start over here with this one. 9/4 equals 30/a. First step is we're going to make the reciprocals of them. So I'm going to make this 4/9 and a/30. So I flipped this one, and to keep it equivalent, I have to flip this one as well. And now it's just like the ones we were doing earlier. I want to get rid of this divide by 30, so I'm going to multiply by 30 on each side. So times 30 times 30. Now I put that 30/1 so that I can go straight across the top. 30 times 4 is 120, and 1 times 9 is 9. On the other side, those 30's canceled out, so I've got a is equal to 120/9, and I can also then divide that out to get my final answer here, which would be, let's see, where's my calculator at? I just set it down. There it is. 120 divided by 9, 13.3 repeating. So A equals 13.3 repeating. That's our answer to that one. Okay. That's all it takes, is flip both fractions and then multiply just like you were doing before. So as I go to the second problem, in order to make it so I can flip both fractions, I have to write this 7 as a fraction, which, as we talked about earlier, to make any number into a fraction, you just put it over 1. So that's 7/1 equals 8/b, which becomes 1/7 equals b/8. So I flipped both fractions after putting that 1 underneath. And now it's just multiply by 8 on each side. So the times 8 cancel to divide by 8. Now here, it might help you to put that 8/1 so that you remember that it's 8 times 1 first, that's 8. And on bottom we got 1 times 7 is 7. So b is 8/7. Or if we want to get the decimal for that, 8 divided by 7 is about 1.1, or 1.14 if you want to get more detailed. So we'll say about 1.1 there. Okay. Last problem then is very similar to the others. We just put this 1.5/1, and then we flip both fractions. So it's going to become c/18 equals 1/1.5. The tricky part about these two is remembering to put them over 1 and then flip them over so the 1 ends up on top. And then it's just like before. We get rid of this divide by 18 by multiplying by 18. It's always the number under the variable that we're multiplying by because we want to get the variable alone. So this becomes 1 times 18 is 18. And on bottom we're going to have 1.5 times 1, or 1.5. And then last step, we just do that division. 18 divided by 1.5, which is 12. So C equals 12 would be our final solution there. And just like with all these others up here, if you wanted to check yourself, you could always put that 12 back in, see if 18 divided by 12 does come out to 1.5. Hopefully that helps.